Hello guys, welcome to another video of additional mathematics. In these video sets, we are going to solve questions from your textbook one by one. If you do not want to miss our videos, please do subscribe to our channel right now. Let's start today's question. This is the first question that we are going to solve, right? So we need to find the Laplace inverse of this. What do we know? We know Laplace inverse of 1 over s minus a is e power at. We know this fact. Using this fact, we need to solve this. How do we do that? See, we already directly we can see there is s minus a, so it will become e power minus 2t. If there is a minus, I got positive. If there is a plus, I should get negative. Is that correct, right? So if I reverse it, e power Laplace of e power minus 2 is 1 by s plus 2. That's what we are feeling here, right? Plus, see, to find Laplace inverse of this, what will I do? I will take 3 outside, and also in the denominator I will take 2 outside. What will happen? See here, if I take 3 from here, 3 will come out, so 1 will be remaining in the numerator. The denominator, if I take 2 common from here, I'll be left with s plus 7 over 2. Is that good? So here 2s plus 7, if I take 2 common, yes, this will be here, plus 7 divided by 2. That's how we have to take, right? So minus, again 4 I need to take common, and I have to take, what else I have to take common? 3 also I will take common. So I'll be left with 1 over s minus 2 by 3. Is that good? Now we will try to find the Laplace inverse of that. So because why did we do this? See, when I was doing the Laplace inverse, the s coefficient is 1. The s coefficient is 1. So here the s coefficient was 2, but we need s coefficient as 1. That's why we have taken whatever the coefficient of s is there, we have to take that common and do the question, right? We already have Laplace inverse of this as this. Let's find Laplace inverse of this. So 3 by 2 is a number. So just let's write e power 2t as it is. 3 by 2 is a number. Let's write down that number. And Laplace inverse of this, how it looks? It looks like 1 by s plus a. So that will get e power, if I have positive, I have to take negative 7 by 2 times t. Isn't it? Minus, again the numbers of 4 over 3, again it looks like we have a negative number, it will become positive. So e power 2 by 3 times t. Is that good? Sure. We'll go to the next question. In the denominator, we have s square and a number. So when we see those things in a denominator, we have s power 2 and a number, right? So we can remember there is only 1 or 2 formulas on that. That is Laplace inverse of a upon s square plus a square is what? Sine 80, right? The same way Laplace inverse of s upon s square plus a square is what? Cos 80. So we'll use these two formulas. And why we didn't consider sine hat cos hat? In the denominator they have a negative, but both of them has a positive denominator, so we didn't consider cos hat and sin hat. Okay, let's solve this. So what do I do? First, what I will do, I'll split these into two terms, that is 2s upon 4s square plus 25, or we can write right here itself, so minus 7 over 4s square plus 25, plus here 8 is there, 8 upon 16 s square plus 9 minus 6s upon 16 s square plus 9. So how do we solve that? Now I need Laplace inverse of this. What I do, I'll take 2 common outside and also denominator. See here, the x square coefficient is only 1, but s square coefficient you have as 4. So I need to take 4 common. So in the denominator, I'll take 4 common. What I'll be left with? The numerator I will having s. The denominator I'll have s square plus 25 by 4. Right? And minus, again, in the denominator 4 is there. So I'll take in numerator 7, I'll take common. In denominator, I'll take 4. So I'll be left with what? I'll be left with 1 over s square plus 25 upon 4. The same way, here I can take 8 over 16, I need to take common. I'll be left with, in a numerator, I'll be left with what? 1 over s square plus 9 upon 16. Is that good? So if I take next what I'll be left with? 6 I will take common, and also in the denominator I'll take 16 common. So what I'll be left with? S upon s square plus 9 over 16. We have learned that Laplace inverse of 1 over s square plus 9 is there. How do we solve this? See, what do we do? Laplace inverse of 1 over s square plus 3 square. Then we solve it, right? So we need 3 square here, right? So what do we do here? See here. We need some square, right? Because it is a square. So what I'll do? I'll take 2 by 4. I'll take s upon s square plus 25 by 4 can be written as what? 5 by 2 whole square. Isn't it? Minus 7 by 4 times. Again, this can be written as what? 1 over s square plus 5 over 4 whole square. Right? And also plus 8 by 16. What can I write this again as? 1 by s square plus 3 by 4 whole square minus 6 over 16 s upon s square plus 3 by 4 whole square. So next I'll write it here. See here, Laplace inverse, everywhere I missed Laplace inverse, so there is a Laplace inverse everywhere, okay? So Laplace inverse of this will become what? In the numerator, if we have s, then pakka it will become a cos, because in the cos we have s by s square plus a square. So first I'll get it as 2 by 4 cos, what is an a? That is the a square, right? That is for 5 by 2. So 5 by 2, 80, right? So minus 7 by 4. See, whenever there is a number 1, right? When there is a number 1, when there is a number in the numerator, that should become sign. But if we have a square, the numerator should be a. So I need to multiply 5 by 4 in the numerator, and the denominator I should multiply with 5 by 4. So what I'll get? I'll multiply with 5 by 4 in the denominator. So if I reciprocate, I'll get 4 by 5, right? So what do I get? 4 by 5 sine 5 by 4 t plus, in the next term, see here, in the denominator I have 3 by 4, in the numerator also I should have 3 by 4. So if I multiply 3 by 4, I should also divide it by 3 by 4. So what I'll get? 8 over 16 into 4 by 3 sine of 3 by 4 t minus, here 6 by 16 we have s in the numerator, so it should be cos, right? So cos, what I will get? 3 by 4 t. Is that cool? Sure. So how do we do it? See, we have, what do we have? We have a minus b whole square. So let's open it. Whenever you find a minus b or a plus b whole square or a plus b whole cube, just open that off. We'll get more clarity on the question. So we'll get s power 4 minus 1, sorry, plus 1 square minus 2 into s square into 1. A minus b whole square is a square plus b square minus 2ab, right? Over s power 6. Now, when you have one denominator and many numerator, just split it up. How to split? CO3, just keep it outside. S power 4 upon s power 6 plus 1 over s power 6 minus 2 into s square, s power 6, no? S square upon s power 6. So, what I'll be left with? 3 times, and this get cancelled. 1 over s square plus 1 over s power 6 minus 2 over s power 4. So what do we know? We know Laplace of t square is what? 2 factorial over s cube. So Laplace inverse of 2 factorial upon s cube is what? T square. So what do we have? See, if there is a number, s power some number, a number minus 1 factorial should be in the numerator, then t power 2 will get, na? So if we have Laplace inverse of let's say 99 factorial upon s power 100 is there, how do we solve? It will become t power this 99, right? So whatever the number of s power is there, that minus 1 factorial should be here, isn't it? So we have s square here. What should be in the numerator? We should have 1 factorial. It is already there. So I'll just take it down. But here we should have 5 factorial in the numerator, but we don't have. What we do? Let's multiply 5 factorial and divide it by 5 factorial and write that, right? So minus 2 into, again I need 3 factorial in the numerator, so I'll multiply, divide 3 factorial and multiply with 3 factorial. So when I put Laplace inverse of these term, now we can directly see 1 by s square Laplace inverse is t power 1 plus 1 by 5 factorial. I'll just keep it as it is, and this number can be written as t power 5 minus again 2 by 3 factorial. Just write, and we can write this as t power 3. Is that cool? Is that cool? Sure.
Guys, if you like the way that we teach, check out our full course which contains all these topics from the basic to the level that you are required for your examination. The link is in the description. And do not forget to share this video with your friends and help them as well. And do not forget to subscribe this channel for more videos like this one. Thanks for watching. All the very best.